Hey Michelle, Jordan here. Let's have a look at what we have today. Now what we have an x and a y, some function here, and our function is 12x cubed. I'm just going to jot that down. We have y equals 12x cubed minus 20x squared plus 9x minus 1. Okay, now here's the deal. We have to use the table to determine a solution. Then we're going to use synthetic division to verify that this number is a solution. Then we're going to solve this for x. Okay? So here's what's going on. First off, we have a 4-term polynomial. We could factor this guy by grouping, but we can also use synthetic division if we know one solution already. So what that means, if I know one solution, I can divide this whole polynomial by that solution. We're going to use synthetic division here because it's quicker than long division. You could use long division too, I guess, but synthetic's quicker. We're going to divide that off, and then we're also going to get our answers as well. So this is useful for those times when we can't really factor easily. I guess you could also still factor it really. Okay, just another method, if you will. So we need one solution, and basically what we need is an x-intercept. So when y is 0, x is 1. So I have a solution already. I know that x is going to be 1. Okay, so that's cool. We have a solution. Now I'm going to take 1, and I'm going to synthetically divide it by what's going on with the rest of this. Now, remember, synthetic division, we only care about the coefficients. So I'm going to write my coefficients, 12. I'm going to write minus 20. Don't forget your minus and plus signs. 9 and minus 1. Okay, so those are just my coefficients, and again I'm making sure that all of this is in standard form, nice descending powers of x ending with our coefficient. Now we synthetically divide. I'm going to drop the 12 down and I multiply. 1 times 12 is 12, and then I add this column right here. So negative 20 plus 12 is going to give me minus 8, and now I repeat the process. 1 times negative 8 is negative 8. When I sum, that's 1. 1 times 1 is 1, and I get a 0. So what this means, our last column here is the remainder. So we have no remainder, which is generally a good thing. So this tells me right off the bat, the fact that we don't have a remainder tells me that 1 is in fact a solution to this. So we just verified that already. What's left now, we could think of this as an x and an x squared. Okay, so and this is just a coefficient. So interestingly enough, if we think about this, we have a polynomial of degree 3 up here. 3 is the highest exponent in any one term. I divide it by a polynomial, or just a constant even. This would be like of degree 1. We wouldn't even write the exponent here, but it would be a 1. But note what happens when I divide a third degree polynomial by a first degree term, I get a second degree polynomial. Okay, so it's kind of like the exponent rule, only, you know, with exponents where you like divide exponents, you subtract the actual exponents itself. It's kind of the same idea. When we divide degrees, we're subtracting the degrees. Anyways, you don't need to know that, but it's just an interesting math geek out thing. So what we have left now is a trinomial. We have 12x squared minus 8x plus 1. And I can still, now we can kind of set that guy equal to 0, and we can solve this as well. We can factor this trinomial. We could do the quadratic formula, whatever the kind of the situation calls for. Let's try to factor them out. So there's a whole bunch of different factors going on here. We have 1 times 12, 2 times 6, 3 times 4. So this is our first term. And over here, this guy's pretty easy. It's just going to be 1 times 1. Or negative 1 times negative 1. Those are really our only two options here. So we want something that will get us a negative 8 at the end of the day. So let's just try, I don't know, 3x and 4x. And this is kind of the guess part right now. So you're probably literally going to watch me guess this out for like 8 minutes. But here we go. All right, so there we go. I had to pause it for a sec. I didn't want to waste your time. But anyway, the two factors that worked are going to be 2x minus 1 and 6x minus 1. And that still equals 0. And if I FOILed this right now, I would get what I started with. So now let's set each factor equal to 0. Kind of the same play that we've been doing all along. I have 6x minus 1 equals 0. And now we're just going to solve using algebra. Okay, so 2x equals 1. And if I divide both sides by 2, x equals 1/2. So that's a solution. And over here, 6x is going to equal 1. And just move the 1 over, divide both sides by 6. And x equals 1/6. So those are our solutions. We have x equals, we can use a little set here. We have 1/6, comma, 1/2, comma, and 1. And remember, 1 is still a solution. We have to list that because I used that up here and I got that from the table. Okay, so now, and you can see I kind of got this wrong too, not reading the question. The solution that can be determined from the table, I noticed you pumped them all in there, but the only one that we can get from this table is 1, right from here. Make y 0, that's our first solution. Then the other two solutions are going to be the two that we just solved from here. So it's going to be 1/6 and 1/2. And there we go. So you were totally on the right track there. I suspect your biggest snag was just right there. They only want the first solution first, and then they want the other two that you found using synthetic division last. So I hope that helps. If not, please let me know.